Ever wonder about vector space and subspace in linear algebra? They might sound intimidating, but they're actually super intuitive once you get the hang of it. Think of them as a mathematical playground for vectors. So what exactly is a vector space? A vector space is just a collection or a set of vectors, but it's not just any set. It has two crucial rules that make it special. Rule 1. You can add any two vectors from the set and their sum will also be in that set. Rule 2. You can multiply any vectors in the set by any scalar. That's just a regular number. And the resulting vector will still be in the set. Now, what about a subspace? Will the name give it away? It's a similar vector space that lives inside a larger one. Think of it as a special mini playground within the big playground. To qualify as a subspace, it needs to meet their specific criteria. Let's check our rules. Number 1. Does it contain the zero vector? Just like the origin, 0 in our 2D plane. Every playground needs a starting point. Number 2. It must be closed under addition. Just like the big vector space, if you add any two vectors from this smaller set, the sum must also be in this smaller set. Number 3. Is it closed under scalar multiplication? If you take any vector from your set and multiply it by any real number, a scalar, the resulting vector must still be in the set. And now let's differentiate vector space from subspace. I will give you 10 questions and you have 15 seconds to answer that. Let's start. If you said vector space, you'd be correct. If you said vector space, you'd be correct. If you said subspace, you'd be correct. If you said subspace, you'd be correct. If you said subspace, you'd be correct. If you said vector space, you'd be correct. If you said subspace, you'd be correct. If you said subspace, you'd be correct. If you said vector space, you'd be wrong. This is not a vector space because multiplying it by the scalar 1/2 leaves you outside the integers. How many did you get? Leave it in the comment section. Now that you understand vector space and subspace, you can now apply this in real life. For example, in vector space, you can use this. Navigating by air and by boat is generally done using vectors. Planes are given a vector to travel, and they use their speed to determine how far they need to go before turning or landing. Sports instruction are based on using vectors. Thank you for
Family is
watching and
love!
subscribe to my channel.
Aba?
This is Kurt Vincent Alancado with my group mates. Goodbye.